Hello, everyone. This is Jason with Hurco Applications. I'm here with you today for the 8th session in our quick training sessions. And today we're going to spend a little bit of time talking about AdaptiPath and kind of some ways to put that to use. We'll show you a little bit about or talk about what it does, and then physically show you how to put it into use. So we will go ahead and get started. To start with, as with our other sessions, I'll go ahead and mention we will be utilizing the WinMax desktop software. For those of you that have already been logging on, you know this is just another solution that Hurco offers, which allows you to do your programming and verification at your desktop. You can then take that program that you create out to your machine and run it there. If any of you are interested in a trial version of that, either to practice what we're going over today or any of the other videos we've done, or to see if that's something that may benefit your shop. At the bottom of the screen you're looking at, you can see that the marketing crew put together a real nice link to make the getting of this software a little easier. But if you just go to hurco.com/software, you can download a trial version of the desktop software, and we can help you with getting that all set up. So you can either follow along with presentations or see if this is something that may be a benefit in your shop. So with that, let's get into AdaptiPath. The first thing that we'll do for those of you that may not be familiar with AdaptiPath is just kind of talk a little bit about what it is or what it does, what are the benefits. First off, AdaptiPath is part of the AltiPockets option on your machine. The majority of the machines out there do have this option on them. So if you have that option, you already have AdaptiPath, assuming your software is up to a version 9 software. If you do have AltiPockets and you don't have AdaptiPath, I will put up the contact information at the end of this presentation. Let us know and we can look at your version and see what it would take to get you to a version that will have AdaptiPath. Once we go through this, you'll see that it is a very beneficial tool. It's going to be something that is going to save you time and money in your machine. So if you don't have the option and it looks like you should, let us know and we will get that all ironed out for you. But AdaptiPath is essentially a pocketing strategy. Now later on in this session, we're going to show you a couple ways to manipulate it so we can use it for some other purposes other than pocketing. But it is primarily a pocketing strategy, which is why it's tied in with that AltiPockets option. The AdaptiPath is basically a constant tool engagement toolpath. There's a lot of these styles of toolpaths out there. A lot of different machine tool manufacturers and CAM systems have versions of this, and they have different names. The one that I tend to use most, other than AdaptiPath, that is, would be high efficiency machining. That kind of describes it a little bit better than some of the others, I think, but you may have heard people refer to things as, dynamic mill, true mill, trochoidal milling. There's many names out there, most of which are escaping me right now, but AdaptiPath is our version of that toolpath. And basically all of these toolpaths have a few similarities between them. And that is going to be, you're going to be taking a large depth of cut with a little bit smaller width of cut. Essentially, whatever your flute length is on your end mill, if you need to go that deep, that's what you're going to take. If you've been watching machining videos or anything like that online, you've probably seen this type of cut. It's what a lot of people are going to get a little bit more efficient toolpath. And we'll kind of show you how the control makes this available or makes this an option. This is a roughing strategy. It's meant to remove material very quickly. So you will typically use a finish pass with this as well. If you don't leave a finish pass, if you do have finished sidewalls, you will see a little bit of marks on those sides because this is intended to be a roughing strategy. It is meant to remove a lot of material very quickly. So with that being said, let's show you a little bit how it does this. Get my screen to advance here. There we go. So I have on the screen a couple tool paths. You know, on the top we have the standard tool path, which is basically you're going to go in, you're going to plunge on center, you're going to step over, and then you're just going to take a cut. In this case, a circular cut, because the finished geometry would be a circle. You're going to machine around, and then when you get to your starting point, you're basically just going to step over and take another circular path or follow your geometry. You're just going to keep doing that, basically stepping over and then cutting the same shape. Well, what we're trying to eliminate here is that step over move. Every time you get to that start point and it comes time to transition over to the next cut, your tool is engaging a lot of material, more material than in your standard routine there. So typically you have to base all your feeds and speeds, your step over, depth of cut, that's all typically based off of that little transition move, because that's where you're going to be engaging the most material. So what AdaptiPath does is, the circle shows it very well here. You're going to start in the middle, and the control is just going to spiral outward at whatever width of cut you gave it, whatever step over you gave it. It's going to spiral outward at a constant spiral, constant step over. When this is cutting, if you were to listen to the machine, you're going to notice that the entire cut sounds the same. You're not getting into those areas where you hear the machine engaging more material and the sound changes. Once you start this spiral, it will never engage more material than what you told it to take, which is how AdaptiPath can allow you to take the larger depth of cuts and use the faster feed rates as well. You will notice that when it gets to the outside edge of this circular shape, there will be some time where it will have to take less of a width of cut. But the important thing here is it will never take a larger width of cut than what you told it to. The theory with these style of cuts is, if you were to picture yourself taking a cut just on the side of this part, you know, maybe you're taking a finished pass or whatever, you're going to give it whatever depth of cut you need. So if you're going 1 inch deep and you have 1 inch flute length on your end mill, you'll just go ahead and take that depth of cut. And if you were to take a straight line cut along the edge of your part, you can dial in your feeds and speeds, width of cut, you know, dial all that in, and then you can use those same parameters for your pocketing, because the control will guarantee that you will never take more than that width of cut that you specified. So the spiral works really well for this circular shape. Obviously, there's times where you're going to need something other than the circular shape. If we take a look at this here, this is a good example of a part that is obviously not circular. And you can see here the control is still going to come in. It's going to start, and it's going to pick a location where it can get the most out of this spiral. And it's going to try to spiral outward until it can no longer hold that step over that you gave it. And anytime it comes to a point where it would have to engage more material, it's going to react in one of two ways. We have two options here, and we'll show you both of those here in a second. But one is a zigzag method, and the other we call OneWay. If you have it set to zigzag, when it comes time to where it would have to engage more material, you know, it's not just going to plunge that tool right through this area here. It is now going to just start cutting back and forth. It's going to zigzag back and forth, holding that width of cut that you specified, or that step over. The important thing is, again, it's not going to engage more material than what you told it to, so you can use those higher depths of cuts and higher feed rates. If you choose the one-way option, rather than zigzagging back and forth, it will take a cut and then do a little transition move to go back to take another cut. So essentially you have the option of climb or conventional. Typically you're going to set this to be a climb cut. It'll basically take a climb cut, do a little transition move back, and take another climb cut, always maintaining that step over that you specified. The one-way method is a little bit more common. You see that used a little bit more. Again, I believe just because of the always climb cutting. But typically when you see these types of tool paths, you'll notice a little arc move like that there, and then just a straight line move to start your other cut or your next cut. That transition move between where it stopped the cut and starts the next cut, it will lift up a little bit in Z as well, so it's not dragging that tool right across your part. So we got two methods which we're going to work with here in just a second, but that is basically how AdaptiPath works. It is going to constantly check your tool engagement to make sure that you never take more of a width of cut than what you specify. So now that we've kind of talked a little bit about it, let's go ahead and put it to use or show you how you would do that. This is where I'm going to bring up the WinMax desktop. And we have a part here that's already been programmed. Let me make sure I'm on the right one. We'll go ahead and draw. So this here is just a standard pocket, nothing more than a mill frame where I put in some different corner radiuses just to show some different geometry so we can kind of see how the AdaptiPath reacts once we turn that on. And we have an island here in the center, again, just to kind of force some different motion out of the software. If we take a look at the data block, nothing out of the ordinary yet. We did utilize the corners tab, which some of you may not be quite as familiar with, but basically I just made one of these arcs a larger arc than the other three. So that gives us the geometry we were just looking at on the screen. And you can see that we did make it a pocket boundary. Now, in order to utilize the AdaptiPath, we're going to go down here to our pocket type. This is where a lot of you are probably used to seeing the inward and outward cut type. We have two more options here now with AdaptiPath. We have the AdaptiPath ZigZag and the OneWay that we mentioned on the previous slide. So we'll go ahead and just choose one of these. I'm going to start with OneWay. And the first thing you may notice if you've been programming with conversational for a while, it just added another tab that you're not used to be seeing. This is a rest tab. This will allow us to go in and clean out any corners that may have been left by too large of a tool. So in this case here, I have a 200 thousandths corner radius on 3 of these 4 corners. And you'll notice that I am using a 3/4 inch end mill. So my roughing tool is just a little bit too large to clean up those corners. Rather than switching to a larger tool, we're going to deal with that in the rest tab here in just a minute. You'll notice my targeted step over, which was 40% in my standard pocketing routine. I'm going to go ahead and back this down a little bit. We'll use about a 20% step over for AdaptiPath. Again, we're going to be taking a much larger depth of cut and a little bit smaller width of cut. I'm going to make sure that my peck depth remains at 0. I want to take this all at one shot. We're only going 3/4 of an inch deep with this pocket. We have a 3/4 inch end mill. As long as we have 3/4 of an inch of flute length, we should be good to go taking this all at one shot. So we'll jump over to the rest machining here. Again, this is going to allow us to go in and kind of clean out these corners that are too small for that larger cutter. If I go ahead and draw this now that we've turned on the AdaptiPath, we'll be able to see that. And some of you may notice if you just start using AdaptiPath for the first time, it will take it a second or two longer to process your tool path if it's a complex pocket. There's just more motion that the control has to work through to do this style of a cut. So that is something that is common with AdaptiPath, you will notice. But if we take a look here, if I zoom in on my corners, you'll see that we have these little moves here to pick out the corners. This is that smaller end mill. We happen to choose a 3/8 end mill to go in and pick out these corners. We can give it a peck depth. Since obviously it's a smaller cutter, you may not want to be going full depth with that, and give it its own speeds and feeds. So you can set this up as its own operation. This is a standard routine. This is kind of like just programming a contour here. There's not going to be any of that constant or any of that engagement checks being done here. It's just going to take the tool that you gave it and go pick out those corners. Now, one exception that you will see when you go to program this is, you notice I've got these lines, this toolpath joining these corners. They had made a change to the software to try to keep the tool down, and are going to be putting this back. Right now, it's actually machining this wall. That will be switched back. It will actually lift the tool up, go to the next peck depth, and then go over to your next corner. So what I'm seeing here will be slightly different than what you will see when you go to program this on your own. Typically, we would just see a rapid move here and then a plunge move down to the next peck depth. But that's the rest machining. Allows you to rough with a tool that's going to be most efficient. Typically the larger the tool, the better. So you can rough out with a little bit larger tool, go in and pick out your corners, and it will do this before it does your finish pass. So you don't have to worry about engaging a bunch of material when you come in to finish this wall. So I used a tool, 3/8 end mill for the rest machining. We will now go into the finish tab. You'll see we're also using that same tool for a finishing pass. As I mentioned before, this is a roughing strategy. So you will want to make sure to go in and program a finish pass. And I'm not sure how many of you have been using the allowance tab here. We did a session on the program parameters, and you remember that if you go into your milling and set your stock allowance mode to data blocks, you can now control all your stock allowances right here in this allowance tab. You will notice that I left my Z depth at 0. If you do leave your Z depth at 0, it will just take the pass around the outside. It won't finish the whole floor. Sometimes that's okay. Other times you may want a little bit nicer finish on your floor. So you can just go in here and give it an allowance for your Z as well. If I go to redraw this now, let's go into my XY view. We've got a couple different things going on. You'll see we have the AdaptiPath. We're taking the cut and then doing the transition back over and taking another cut. But you'll also now see that we have what looks like a standard pocketing routine there as well. When you take a finish pass, that will always be the standard pocketing routine. It's not going to be doing the AdaptiPath style of cut, which is typically fine. You've gotten all the material out of there. Now you're just finishing that floor. So you will notice that your finishing pass will always be the standard routine. And you do have all the same control in your finishing pass as you do on your standard pocketing or the roughing, where you can set the step over and speeds and feeds. So that is the basics of how you work with AdaptiPath. And notice it's not a whole lot to get it to work other than what you're already used to in setting your pocket type when you set your milling type. With the addition of the rest machining, notice we do have the arrows. That can take a little bit of getting used to for those of you that haven't had to use those in the past. You may need to hit these arrows to kind of be able to see all the tabs that you need to work with. But other than that, that's kind of how AdaptiPath works. Now there's a couple things we can do in here to make it, so we can use it in other ways. Let's go in and take a look at another option here. I'm sorry for my poking around here. I thought I had created one other program. All right, yeah, we're going to let this one go. I'm going to pull up another program here. Sorry about that. So the next thing I kind of want to talk about is open pocket. There are times when you're programming where maybe you want to leave an open pocket so you can come in and essentially plunge outside of your stock. This is a very efficient method for removing material. So there's a lot of times this will be your go-to strategy for removing a lot of material. But let's say we had a part that looks something like this here, just a simple frame. I did set up some stock geometry, so this does represent the stock that I've put in the machine. But let's say we want to machine all this away. We want this to be an island. Now we could very easily just go in and program a frame on the outside of this and tell it that's a boundary and that this frame on the center is an island, and it would go ahead and machine all that away and do a pretty efficient job at it. But since we are removing all the material, we have one advantage here that we may not typically have in most pockets, and that is we could easily go in and plunge outside of our material so that we don't have to take the time to helix in. It'll be a little easier on the tool, and we'll be able to get that plunge move done quicker. So I'm going to walk through how to do that. Let me go in. I'm just checking my stock geometry so I can check my stock size here. So we have a 6x6 by 1 inch piece of material. And by the reference position here, I can see that part 0 is right in the middle. So that gives me what I need to do to start programming. So what I'm going to do is I'm going to insert a block before this frame, and I'm just going to go into lines and arcs, and I'm going to just program a U shape or a C shape that's just slightly larger than the stock that I have, and I'm going to leave one side open. So we'll just start, let's say I'm going to start at an X of minus 3.25 and a Y of minus 3.25. I think that frame was going a 1/2 inch deep, so we'll take a look at that. So I'll go to my next segment, and at minus 3.25 and a Y of positive 3.25. Continue over to positive 3.25 and X and Y. And then my next segment will be my final segment. I'm going to end at 3.25 and my Y will be minus 3.25. So if you were able to follow along, I know it's kind of hard without prints and dimensions. If I look at my graphic screen, let me minimize this just for a second. Essentially what I've done is I've come in and I've programmed something just like that there, just an open boundary on the outside of my part. So now we'll go put this to use. I'm going to tell what tool I want to use. I'm going to tell it I want to do a pocket boundary. And now I'm just going to go ahead and set AdaptiPath just like we did before, and I'll give it my step over. The nice thing about AdaptiPath, for those of you that are used to open pockets in the past, you had to go in and there was a few steps and things that you had to do to make sure that everything worked the way you wanted. With AdaptiPath, that's not necessary. We just leave the open boundary. As soon as we set it to AdaptiPath, it's going to look at it slightly different. And when we go to draw this, we should see we now have, I made yet another mistake on this part here. I forgot to turn this frame into an island. We'll go fix that. But you'll notice that we're now plunging on the outside of our stock, and it's using our step over and that constant engagement. It's always checking that step over to make sure that we never engage more material than what we told it. So let me go ahead and fix the program. I'm just going to go into my second data block, the mill frame. I'm going to set that to a pocket island. Now when I draw this, You can kind of see what we've got going on here. We're using the AdaptiPath style. It's going to keep stepping over at whatever your width of cut is until it can no longer do so, and then it's either going to use your one-way or zigzag to remove the rest of the material. Now there's two other things I need to kind of mention here. One of them is there is a new parameter that you are not going to be familiar with if you haven't used AdaptiPath before. If we go into our program parameters in the Milling 2 tab, we now have this AdaptiPath link length tolerance multiplier. If we look at the description down here, AdaptiPath link moves above this tolerance, will retract at rapid, then plunge. So what this is wanting to know is if it has to make a transition, do you want it to pick up the tool or leave it down? Typically, I will set this to the largest value that it'll take, which is 100, and try to force it to keep that tool down as much as possible. If there are any islands or anything in the way, the control is still going to be checking against those, so you don't have to worry about it wiping out an island or anything like that. So I typically just leave my tool down as much as possible, remembering that it will, if you're doing the D move or the little transition moves, it will pick up slightly so it's not dragging on the floor. So I typically will put this in at about 100. And when I go to draw this, you may notice that some of these plunge moves down here in the lower right-hand corner may go away. In this case here, it's a pretty large part, so we may not get all of those gone. But yeah, so now you can see here, we have one plunge versus however many were there before. So basically that parameter is just telling it, to keep the tool down for that given distance before having to retract. So that's how you would use open pockets. It's very simple. Just leave your pocket open and tell it you want to do an adaptive path. Now there's one other feature, and this was the feature I was looking for just a minute ago when I started fumbling around with programs. Expand boundary. This is primarily used if you're importing data in from a DXF file or a solid model or something like that there, where you're just going to select geometry. If you have geometry that is to the print and you want to make sure you step over a little further to clean it up, to make sure you don't leave any material standing, you can go in and tell it you want to expand the boundary. So when we programmed this, we went ahead and we compensated ourselves. We went to -3¼ in X instead of just going to -3 inches. So we compensated for that ourselves. If this was a closed boundary and we wanted the control to do that for us automatically, we can just go in there, tell it, yes, I want to expand the boundary, and have given it that 1/4 inch distance there. So at this time, this is just for closed geometry. And so if you were to maybe import a frame or something similar to that in from a solid model from your graphic screen, you could then just go in and tell it you wanted to expand that distance to make sure you cleaned everything up. So that there is essentially what we have to offer there with AdaptiPath. I'm going to go ahead and take a look at the chat section here to see what questions have come up. If you have any questions, you can feel free to unmute yourself or go ahead and ask them in the chat menu or chat window. Give me one second here, and I'll take a look. Okay, Luke has a good question here. What is the average cycle time advantage over standard outward or inward milling routines? This is somewhat of a hard one to answer because it's very application specific, and it depends on the depth and everything that you're programming. But your standard pockets, you are going to see considerable cutting time reduction. And let me take a look for one folder here. I believe I have a picture of one example. Yeah, a lot of the images I have here have been taken from a presentation that Mike Cope had done a while ago, and I happen to find this in there as well. This is actually that first shape we were kind of talking about, AdaptiPath, but you can see with the standard WinMax toolpath, it was 6 minutes and 3 seconds. With AdaptiPath, you're 2 minutes and 23 seconds. This is primarily coming, or due to the fact that you're probably going to take this entire pocket at one shot. You're not going to take the small pecks at it. Some of the other advantages come in that you can physically run your tools faster and feed them harder. It seems that the tool manufacturers prefer this style of cutting. And once you start doing this, it's kind of amazing how much faster you can kind of feed things through the part. So I don't know what it's not always going to be a little different. You can see on this part, it was 62% faster. That's probably, I don't know if that would be kind of standard what you'd expect to see. It seems like it is quite a bit faster there. I would say you're typically going to be about half or so, but it is very application specific. And Dean asked us, do you have to be on version 9 or newer? And yes, you do. This was an option that was brought in on version 9, so it won't be available on the version 7 or 8 software. And Doug is asking about a specific application here. What if you have notches on the inside of a part? Doug had shared a picture with me a while ago of a specific part, and basically what it was a circle with some, let's say, frames cut in the outside of it. What I would do on that type of application is I would probably program one of those frames as an open contour and just make it extend out just a little bit past your circular pocket. Let it machine all of that away, and then just do a pattern to rotate it around. I think is how I would do that. Luke had another good comment here on one of the application engineers. He works for one of our distributors. He was saying his engineer was able to push a tool at 350 inches a minute on a VM10 using a coated end mill in 4140. It was using AdaptiPath and cut dry. So we kind of see this a lot. You will notice when you're watching these videos, a lot of times you will see guys cutting dry. And a lot of that is just due to the fact that when you're cutting, your feed rates are higher. You're typically throwing these chips well out of the hole that you're in. And a lot of the tools now are kind of designed to be cut dry. So, yeah, that was a good example of what you can expect with AdaptiPath. All right, are there any other questions on AdaptiPath? If not, I'll go ahead and stop the recording and we can kind of have a question and answer session on any topic or maybe suggestions or anything like that. But we'll give you a minute or so here to see if there's any other AdaptiPath questions.